The Boeing Company's mission is to connect, protect, explore and inspire the world through aerospace innovation in the areas of commercial, defence and space, global services and Boeing Capital. Present in over 150 countries, the organisation has over 150,000 employees globally. Established in 2008, Boeing Research and Technology Australia aims to support business operations by providing a focal point for collaboration in research and development, both in Australia and globally. The organisation seeks to improve cycle time, cost, quality and performance of current aerospace manufacturing systems. This is based on the pre-established capability of mobile robots coming to the plane components and work areas which are fixed in position, rather than the plane components being moved to the fixed position robots. Due to the scale of operations, Boeing is considering the eligibility of mobilising its manufacturing robots, hence the need for reliable position tracking. To achieve this effectively creates the necessity for competent location services, so to enable the robots to not only locate the tools for a specific task, but also avoid hazardous and costly collisions. Firstly, the system must be able to respond to requests for locations of assets within a designated period of time. Secondly, the system will format sensor input for two types of sensors and store this data. Lastly, the system will determine the certainty of an object's position based upon its characteristics, such as tag location and origin of an object. The factory environment will have cameras and RFID sensors installed in key positions throughout the infrastructure. To calculate the location of an object, a number of inverse calculations are required to correlate the object's location to the world origin. The camera knows where a tag is in relation to its own reference frame. The location of a camera is also known, which is required to locate the location of the tag. Knowing where a tag is on the object allows the system to calculate the origin of the object relative to the world frame. This will generate sensor readings that enter the system. Next, the sensor readings will be passed to the system's backend, which will format the data and associate this to an object, identified through querying the object database. Once associated, the system uses the world map as a reference to calculate the latest covariance and pose, or simply geometry of that object. The system then posts this to the REST API, from which the robot can use and access the information by performing a GET query on the REST API. The location of that object is then used by the cobot to perform tasks in the factory environment. For project management techniques, we have been using Slack, GitHub, Project Gantt, Trello, and Google Drive for administration. To achieve this, we are going to be developing in C++ using the Eigenmatrix library, various Kalman filtering and smoothing libraries, as well as the InfluxDB time series database. We are on schedule with our project execution until this point, and we aim to have most of the formatting and filtering complete in the early stages of Semester 2. With the 6 of us on this project, if successful, this will satisfy the requirements in terms of location services to mobilise Boeing's robots, and ultimately, streamline manufacturing efficiency and capabilities.